Okay, so you can upload your topic 2 from author. Okay, you can see my slide. Boleh nampak slide saya? Nampak Okay. So if you can see this slide. Okay, so we start our topic 2 today. Okay. So in topic 2 in part A, so more discuss more on the hydrostatic pressure and buoyancy. Okay, so they have two subtopic. Okay, so two subtopic in this. Boleh nampak ke? Okay. So learning outcome at the end of this chapter, students should be able to understand and analyze hydrostatic pressure and buoyancy. Okay, so the subtopic 1. Okay. So and list out and apply equation of hydrostatic pressure and buoyancy. Okay, so the two subtopic. Okay, based on pressure and hydrostatic pressure and buoyancy. Okay, for first, okay, we based on pressure head. Okay, so you must know what is the pressure that I mentioned in topic 1. Okay, so compressibility and so on, density. So you will also use that equation in topic 2. So that's why in this topic 2, so you must learn what is the pressure, what is the pressure measurement, okay, what is the hydrostatic force, okay, and so on. So now, so we look at the pressure here. So pressure is defined as a normal force exerted by a fluid per unit area. Okay, pressure is defined as force per unit area. So use the unit Newton per meter squared. Okay, Newton per meter squared. Okay, just correct the Newton per meter squared, which is also called a Pascal. PA here. Okay. So this is the unit for pressure. Okay, 1 Pascal is equal to 1 Newton per meter square. So you must remember this unit for pressure. Okay, now we look at the three other pressure that we also use. Okay, if you can see the pressure unit based on the bar, standard atmosphere, and kilogram force per square centimeter. So this is you can find from the other reference book. Okay, 1 bar is equal to 1 times by 10 power 5 Pascal. Okay, so 1 bar is equal to this one, Pascal. So Pascal you convert to megapascal and you can convert to kilopascal. Okay, 1 atmosphere is equal to 101,325 Pascal. Okay, this is pressure of 1 atmosphere. So it's equal to 101.325 kilopascal or 1.01325 bars. Okay, so this is the conversion unit that you must know. Okay, but you don't worry. Actually, for 1 atmosphere, I will give the value for 1 atmosphere. Okay. So pressure for atmosphere pressure. So I will give you the value. This one. Okay. So using a 1 kilogram force per centimeter squared is also in Newton per centimeter squared. Okay. And you can convert to Newton meter and Pascal, bar, and atmosphere. So this is the conversion unit. Okay, from bar to kilopascal, from atmosphere to bar, and so on. Okay, so now you look at this person. Okay, with the different weight. Okay, and this different pressure here. Okay, but the area of fit is the same. Okay, area fit of these two person is the same. So the pressure, okay, for this person 150 pounds and the 300 pounds. So the pressure is based on this. You are the equation here. Okay, pressure is equal to W is a weight divide by area. Okay, area in feet. So this is in feet, PSI unit. Okay, so pressure that we have learned in SI unit, so we use the Newton per meter squared. Okay, using the SI unit. Okay, so the normal stress or pressure on the feet of a chubby person here, okay, is much greater than on the feet of a slim person. Okay, so that's the normal stress or pressure. Okay, so now the actual pressure at a given position is called the absolute pressure. Okay, semua dah masuk okay. So the actual pressure, so in this pressure, so you must know the three pressure. Okay, absolute pressure. Okay, the absolute pressure, the vacuum, the absolute pressure, the absolute vacuum or absolute zero pressure, the gauge pressure, okay, and the vacuum pressure. Okay, actually for these three types of the pressure, so this refer to this concept here, the figure here. Okay, to get the P vacuum here, so you must know that the P atmosphere minus by P absolute, so you get the P vac. Okay, or you have the P vacuum and you have the P atmosphere, so you get the P absolute is P atmosphere minus by P vac, so you get the P absolute. Or you want to find the P atmosphere, so P absolute plus the P vac, so you get the P atmosphere. So this is the based on this figure. And or to find the P gauge here, okay, so you have the P absolute, so P absolute minus by P atmosphere, so you get the P gauge here. Okay, so actually the pressure below atmospheric pressure are called vacuum. Okay, below the P atmosphere, so we call the P vacuum pressure, and are measured by a vacuum gauge that indicate the difference between the atmospheric pressure and the absolute pressure. So you just know this equation. So actually they have the equation here. Okay, forget to put here. Okay, but you can look at this. Okay, and this is the equation. Okay, the equation based on the figure previous. Okay, previous slide. So you must know that this P absolute is equal to P atmosphere minus by P vac. Okay, actually to get the this one. Okay, to get the P absolute, so the P atmosphere minus by P vacuum, so you get the P absolute. Okay, so the P absolute is equal to P atmosphere minus by P vacuum. Okay, so a vacuum gauge connected to a chamber reeds. Okay, chamber reeds is the P. Okay, P vac here. Okay, to P vacuum gauge. Okay, the P vacuum gauge connected to a chamber reads 5.8 Pascal. Okay, at a location where the atmospheric pressure, okay, is 101.3 kilopascal. Okay, so the atmospheric pressure. So determine the absolute pressure in the chamber. Okay, to find the absolute pressure. So you just direct use this equation. Okay, so use that equation. P absolute is equal to P atmosphere minus by P vac. Okay, so you get the value. Just put the value here and you get the value of P absolute. Okay, just remember this equation. So this equation is not given. Okay, so this equation is not given in your test or in your final. Okay, so you just remember what is the P absolute, what is the P atmosphere, and what is the P vacuum. Okay, so now we look at the example 2.2. Okay, find the absolute pressure in kilopascal unit if barometer shows the reading of 60 kilopascal. Okay, so the given barometer reading at sea level, okay, 2740 mmHg is actually this is a barometer reading based on mercury. Okay, barometer reading is the based on the mercury here as Hg. Okay, so and the specific gravity of mercury. Okay, so now to find the specific gravity also, so you must refer also the calculation, okay, the equation based on topic 1. Okay, the specific gravity of mercury is this one, and they give you barometer reading. Okay, the given is gauge pressure as P gauge. Okay, P gauge is 60 kilopascal here. Okay, the barometer reading is 740 mmHg and the SG of mercury is 13.6. Okay, to find the absolute pressure. So now look here. Okay, so we know that, so this is the equation for get the P absolute based on the equation of P gauge and the P atmosphere. Okay, so this equation is based on this figure here. Okay, based on the P gauge and the P atmosphere. Okay, to get the P absolute, to get the P gauge and the P atmosphere. Okay, but for this concept, P atmosphere, they give you the P absolute and the P vac. So you can use the equation for this one. And the other figure is use this equation here. Okay, use the P gauge plus P atmosphere. Okay, so we know that the P atmosphere you is a P density of mercury. Okay, times by G times by H. Okay, so we know that the density of mercury, find the P mercury based on Sg. Okay, so Sg of mercury, okay, we know that the Sg in topic 1, you must know that the density of fluid, okay, density of mercury divided by density of water. Okay, okay, so you get the Sg mercury is given. Okay, the P density of water, we know that is 1000. So just we get the density of mercury. So density of mercury is Sg times by the 1000 times by the G here and H. H is based on barometer reading. Okay, barometer reading is 740 mm. So you convert to meter. Okay, so you convert to meter, you just divide by 1000 here. So you get the P atmosphere is this one. Okay, 98.73 kilopascal. Okay, so this is for P atmosphere. Okay, so you must find the P atmosphere based on barometer reading, based on the P gauge, and you get the P absolute based on this equation. Okay, okay, 60 plus P atmosphere here. So you get the 158.73 kilopascal. Okay, so this is the direct equation. Okay, so first you must remember this equation and the previous equation that I mentioned from the previous slide. Okay, so the P absolute using P gauge and P atmosphere, and P absolute using P atmosphere and P vacuum. Okay, so they have two equation for pressure. Okay, pressure absolute, pressure atmosphere, pressure vacuum, and pressure gauge. Okay, so now we look at the variation of pressure with depth. Okay, so with depth here, okay, so the pressure, okay, based on this is surface water, okay, and they have the depth of water here, okay, so and they have the P gauge, pressure gauge in this water, okay, so pressure in a fluid increase with depth. Okay, so this is the theory. Okay, so in case for your test or your final, ask you to explain. Okay, explain about pressure with that. Okay, so you can explain, you sketch this figure. Okay, you explain that pressure in a fluid will increase with depth because more fluid rests on deeper layers. Okay, and the effects of this extra weight on a deeper layer, okay, from this actually water here, so they have the variation of depth. So deeper layer is balanced by an increase in pressure. Okay, so maksudnya tekanannya semakin tinggi lah. Tekanan semakin tinggi bila kedalaman semakin dalam. Okay, so that's why the variation of pressure with depth. So you can mention for this theory. So the pressure of a fluid at rest increase with depth as a result of added weight. Okay, so this is as the your knowledge, okay, based on this theory. Okay, So this is also the fluid here, also the fluid with the weight of this liquid. Okay, so to obtain a relation for the variation of pressure with depth, okay, with the depth here, okay, consider a rectangular fluid element. So kita will assume that is considered as the rectangular. Okay, they have the force here, the pressure around this surrounding from this fluid. Okay, so they have the P1 here, they have the P2 here, and also the pressure at this side and pressure at this side here. Okay, and the weight of this liquid also you must consider. Okay, so the length of this pressure, okay, the length here and the length of this part here is delta z, and the length is delta x. Okay, so at the horizontal is delta x and the vertical is delta z here. Okay, so assuming the density of the fluid r, okay, fluid of this we just assume as the fluid r, or we don't know what is the fluid. Okay, so that's we assume as the fluid r to be constant. A force balance in the vertical z, okay, vertical z, okay, direction give of this. We know that the force, okay, force of this, okay, force in this liquid is equal to m is the mass, okay, mass of this liquid, okay, times by the a, okay, area. Okay, so it's also, we know that the force, okay, from the force here, okay, so we know that the mass, so based on from the P here, okay, so P2 pressure or pressure 2 here, okay, because the arrow is up, okay, so this is plus, okay, so arrow is go down here, downward to, so this is negative, so negative P1 times by the length of delta x here. Okay, and the P2 is P2 times by the delta x also. Okay, so because this is the horizontal, so mass times by the horizontal here, the pressure here. Okay, upper and from the below here. Okay, so we times by the delta x. Okay, and also the based on the pressure around this liquid. So that's why density of liquid times by the G, okay, times by delta X and delta Z here, because the area in this rectangular, okay, so the rectangular fluid element. So that's why we get the P2 delta X minus by P1 delta X minus density times by G delta X delta Z. Okay, actually this is based on for this one. Okay, for this, consider for this one. Okay, sorry, consider for P2 here. Okay, consider for P1 here. Okay, and P2 based on this one, consider for this P2. Okay, and this around this here is for this one. Okay, so this is called that force balance in the vertical z direction is given as this one. Okay, so this is theory. Okay, so maybe in your test or in your final, ask you to explain. Okay, explain if this diagram given. Okay, maybe the diagram is given to you, or this diagram given to you. Okay, or this diagram, or this, okay, or this figure, or this figure. Okay, so you can explain based on this theory. Okay, so maybe they ask you to state the equation for balance, okay, for balance in this direction. Okay, maybe so you can explain for this direction and explain about this figure. Okay, so that's it for theory. Okay, now we look at the concept of this. Okay, based on the, this is surface water here. Okay, water level here. Okay, they have the point 1 here, okay, and the point 2 here with the depth of H. Okay, so if we take point 1, okay, to be at the free surface of a liquid open to the atmosphere. Okay, so open to the atmosphere, so that's why the pressure at 1 here is same as the pressure atmosphere. Okay, so kena sama maksudnya kena ingat pada point 1 ini yang terletak open to the atmosphere, so that pressure is the same. Okay, so P1 is the same pressure as the pressure atmosphere. Okay, so then the pressure at the depth H with the pressure of depth here from the free surface becomes P2. So the at the point 2 here, so they have the pressure here. Okay, rho G H. Okay, based on this depth. Okay, that's why this for this. Okay, so to get the pressure 2 here, so they must include the pressure at point 1 plus pressure at this rho GH here. So that's why you get the pressure for pressure 2 is equation of pressure 1. Actually, to get the pressure 2, okay, so you must know that the pressure 1 plus pressure at this depth, okay, pressure at this depth of H. So that's why you must density of fluid times by the G times by the H. Based on this, okay, refer to this pressure, okay, pressure in this, actually the pressure, okay, with that depth, okay, the figure is like this one, okay, with the depth. Okay, so the figure is like the previous of slide. Okay, so at the pressure at this H. Okay, that's why we get the P2 is equal to P1 plus P rho GH. Okay, so P1 we know that is same as P atmosphere. So you get the P atmosphere plus rho GH. Okay, so this is the P2. Pressure at 2. Okay, so you get the pressure at 2 here based on the P atmosphere plus rho GH. So it's actually this is pressure 2. Okay, and we know that the P gauge is rho GH. So this is called sorry, the pressure gauge here. Okay, so this is called pressure gauge. So pressure gauge is density times by the G times by the H. Okay. Okay, so that's okay. Now we look at the concept for this pressure. Okay, based on this, okay, the depth here. Okay, with the depth here. Okay, with the depth of H. Okay, and we have the level, the same level here, A, B, C. Okay, we have the level. Okay, with the same level A, B, C. Maksudnya level yang sama Okay, pada kedalaman yang sama with the same. So pada with the same H here, with the same H and with the same fluid. So the fluid is water. Okay. So pada paras yang sama ni adalah digunakan the same fluid, water and the same H. So that's why pressure at A here is equal to pressure at B. Pressure at C, pressure at D, E, F, G. So the pressure is the same. Okay. So the pressure is same with the same level and with the same height. Okay, the depth. Okay, with the same depth. So we get the P atmosphere plus the P gauge here. Okay, so we get the P atmosphere plus P gauge is rho GH. Okay, because the H the same. Okay, but when we look at the H and I, so it's not the same. Okay, not the same pressure because the difference fluid. Okay, with the same height, okay, H plus and the other H here, okay, but at the H is also include the mercury and the water. Okay, they include the mercury and the water. Okay, so this is the mercury and this is the water. So they include two different fluid. But for the I here, just only water. So that's why the P pressure and H is not the same as pressure at I. Okay, so because they have different fluid, different the same height. Okay, maybe H plus the same H. Okay, so maybe the H2 here. Okay, but they have the difference fluid here. Okay, for the H, they have two different fluid, water and mercury, and I here is just only water. Okay, so that's why the pressure is not the same. Okay, so at this one, A, B, C, D, E, F, G, so and the pressure is same. Okay, so pressure in a fluid at rest is independent of the shape of cross section of the container. It change with the vertical distance. Okay, the vertical distance here, but remains constant in other directions. So therefore, the pressure in the same at all points on a horizontal plane in a given fluid. Okay, so you can explain based on this theory. Okay, in case kalau ada soalan keluar macam ni, okay, they give you that the figure like this one, maybe the shape is not as same as this one. Okay, so you can explain, okay, based on the same level, okay, and the same fluid and with the same depth. Okay, so you can explain based on this concept for variation of depth. Okay, the pressure. Okay, now we look at this is the also the fluid. Okay, forces of the fluid, but they have the three surface. They have surface of PS here, pressure at the S, and surface for PX here. Okay, and pressure at the surface of Y, vertical. Okay, the X here and the S here. Okay, so since there can be no sharing force for a fluid at rest, okay, there will be no accelerating forces. The sum of the forces in any direction must therefore be zero. Okay, so the forces acting are due to the pressure on the surrounding and that gravity forces. Okay, so they have the three direction of force. Okay, they have the px here, they have the py here, and they have ps here. Okay, so px is in x direction. Okay, py is y direction. So ps, they include y and x and y. Okay, okay, because dia ada bersudut, dia condong macam ni, they have as like this one, so they must also include the x. Okay, and also includes this include the y direction and include the x direction. Okay, so this x is x direction. Okay, so this is y direction. Okay, so for the PS, they have y and they were y direction and x direction. So that's we look at the forces due to PX. Okay, forces due to PX. Okay, due to PX for this one. Okay, forces for x direction for PX. Okay, so forces are force due to PX is equal to PX times by the area of A, B, E, F. Okay, so this is for x direction. Okay, so this is called for the x direction. Okay, so px, okay, times by the area of A, B, E, F. Okay, so length of AE is dy, length of AB is dz. So that's why px times by dy times by dz. Okay, so that you get the dy and dz here. Okay, so you get the pressure. Okay, pressure for x direction. So this is called pressure at x direction. So we get the px times by dy times by dz. Okay, so now we look at the horizontal component of force due to ps. Okay, so due to ps we have two components. Okay, horizontal and also vertical. Okay, so that's why we look at first we look at the x direction. So for horizontal component here, so this is horizontal components of ps. So horizontal for x direction, so we look at this part here. Okay, so PS Okay, times by the dash, the ds here, and the dz here. So the area of this part. Okay, so that's why. So you must horizontal component of force due to ps is y negative, because the arrow of this x direction is the x direction positive is go to 3, this one. Okay, go to right side. Okay, based on arrow is go to left side, because consider based on this direction. Okay, the direction of the arrow, the blue arrow here. Okay, so the x direction is this one, base go to left side. So that's why left side we put the negative here. Okay, so ps, okay, ps is the pressure on s, and times by the area a b c d, times by the sine q. Okay, because they have the condongnya dia ada sudut lah. Okay, the based on sine q here. Okay, so that's why ps times by the area a b c d times by sine q. Okay, sine theta sini actually sine theta. Okay, actually at times sine this one. Okay, so we get the negative ps, so negative ps times by ds dz. Okay, ds dz times by dy ds. Actually dy ds, this is based on the sine theta here. So we get the negative ps dy dz. So we get the negative ps dy dz. Okay, based on the there's no ds here. Okay, so we just look at the part here. Okay, until you get the based on this one, negative ps times by dy dz. So actually to get the force of ps, okay, so you must know that pressure, negative pressure of ps times by dy dz. So this is for x direction. Okay, so we know that the y no direction. Okay, no x direction for py, so they have y direction. So the calculation for this force is only for px and the ps. Okay, with the x direction. Okay, so we get the, just put this as the same here. So we know that the px, okay, px is equal to ps because at the x direction. Okay, so you just put here. Okay, so you get the equilibrium. Okay, so untuk maksudnya dia nak sambungkan balance so to balance balance with the force, so you must put the px is equal to ps here. So you just put the px dy dz here. The px is plus minus, so this is to get here is equal to 0. Okay, for this is ps dy is negative, so you just go to the left here. We get the negative here for the ps. Okay, so we get is this one. Okay, so no need to worry about this one. Okay, so actually for this equation is given. Okay, so jangan risau. So this equation I will give to you. Okay, force based on this. Okay, force based on this fluid. Kalau ada bentuk fluid macam ni, based on the forces based on 3 directions. So I will give you the equation here. Okay, the based on this one. Okay, so now we look at the y direction. So this is y direction. So y direction just only have the py and also the ps here for the y direction. So we look at the py. Okay, so py pressure at y is equal to py times by dx by dz, because the length of dx and the dz here. So the py times by the area of this part here. So we get the this one. Okay, since dx, dy, and dz are very small quantities, dy, dx, dy is negligible in comparison with other two vertical. So no need to worry about this one. Okay, so components of force due to ps. Okay, the ps is x direction, this is y direction. So also negative because the y is go down. Okay, so the arrow is draw down in there. So this negative also. Okay, the negative. So this also negative. Okay, so that's why you get the negative PS times by the area. Okay, area A, B, C, D. Okay, times by the cos theta here. Okay, cos theta here. Okay, so you get the negative PS ds dz times by the dx ds. Dx is based on the cos here. Okay, cos theta here is you get the dx divided by ds. Okay, so until you get the dx ds. Okay, so we get the negative ps dx dz. Okay, so we get the px py. Okay, so kita boleh samakan lah. Okay, so kita samakan. Since dx, dy and dz are very small quantities, okay, dx, dy, dz is negligible in comparison with other two vertical. Okay, py is equal to ps. Okay, after we know that at the x direction, px is equal to ps, and y direction, py is equal to ps. So we get the px is equal to py is equal to ps. Okay, so panjang So this is theory. Okay, no need to worry about this theory. You just remember this concept here. Okay, Px must equal to Py must equal to Ps. So we call it the Pascal law. Okay, so ingat Pascal law je lah. So this theory, okay, if in test or in your final ask you to explain briefly about Pascal law, okay, so you can explain about this Pascal law. Okay, pressure at a point is same in all direction. So you just mention that Pascal law. Okay, pressure at a point is same in all direction. So you draw this diagram here. Okay, px, py, ps. So you just put this one. Px is equal to py is equal to ps. So is you get 5 mark or 6 mark, okay, for explain. Okay, so explain briefly about the Pascal law, and you show the diagram, and you just put the equation here, and this one, and also px equal to ps. Okay, so you get the full mark for this theory. Okay, so this is for theory. Okay, you can read after this. Okay, so now this is concept for pressure and the force. Okay, so this concept actually is from the previous, actually from this Pascal law. Okay, from this force and the pressure. So we can put here based on this concept for this. Okay, for this at the point 1 here and the point 2 here. Okay, so we know that the force of this K of F1, okay, is the force 1 here, is pressure 1 times by the area of 1 here, area of this part. Okay. Okay, and also the P2 pressure at 2 and area of 2 here is based on this one. Okay, so they have the pressure for uplift the car here. So the just go through here. So we know that at the same level, so this is concept as the Pascal law. Okay, so at the same level here. Okay, so they have the, maksudnya the oboe ni, maksudnya that this part here at the same level. So that's why we get put here as the point 1 and put here as the point 2 here. Okay, so we get this is the at the pressure at point 1, pressure at point 2. Okay, so with the Pascal law, so we put here as pressure at 1 is equal to pressure at 2 because at the same level here. Okay, so we assume that for Pascal law, at this level, so pressure at 1 is equal to pressure at 2. Okay, so we know that the pressure 1, okay, pressure 1 is equal to F4. Okay, F1 divided by A1. Okay, so it's the concept same. So we put here as F1 divided by A1 for P1. Okay, and F2, so P1, so we get this one. Okay, P2, so we get this one. So until you just convert to this F2 over F1, is equal to A2 over A1, or you want to put here as sorry, yeah. Okay, so now we look at this concept. Okay. Okay, after we get this, okay, F1, we get also the F2 here. So maybe we can put here as if you want to put F1 above and F2 below. Okay, so you get the A1 over A2. Okay, so boleh lah. So based on this equation or this equation, so you can use. Okay, so based on this one. So actually, for this concept of Pascal law, so you must put at the same level. So you must know that the pressure at 1 is equal to pressure at 2. Okay, using this Pascal law. Okay, so lifting of a large weight by a small force by the application of Pascal law. So this is based on Pascal law. Okay, so now we look at the example here. What is the pressure difference in 1 meter of seawater compared with 100 meter of seawater? Okay, so actually this example 2.3 is based on this concept. Okay, this is water level. Okay, they have the H. Okay, okay, maybe H is at 1 meter, maybe H at the 100 meter. Okay, so you must, this is at point 1 and you want to find at the point 2. Okay, point 2 based on this depth of water. Okay, so you must put the P1 here, okay, and the P2 here. So to get the P1, P1 is P atmosphere, okay, because the water is open to the atmosphere. Okay, so and to get the P2, so you must know that P1, okay, plus the big gauge here in this water, seawater. So you get the rho GH. Okay, so you use this question. Okay, the P1 is P atmospheric pressure. So use this equation here. Okay, put the value here. And density of seawater here. Okay, so density of seawater, you just put here. Okay. Okay, this is not this one. This is negative. Okay, sini correct the. Okay, so just density of seawater times by the G, 9.81 times by the H. H is 1 meter. So you get the value of this one. Okay, actually this is for the concept for like this one. Okay, at the previous slide, the diagram. Okay, so now we look at the H is 100 meter. Okay, so you just also use this equation, the concept of this Pascal law. Okay, just put the value here and you use the 100 meter here. Okay, so actually any typing error, so typing error, so you just this is here. Okay, just correct the, so you get the value of this one. So to get the pressure difference from H1 meter to 100 meter. So you get the difference is just minus, okay? Just minus the 100 meter minus to the 1 meter. So you get the value of 9.75 times by, okay, actually times, okay, times 10 power 5 Pascal. So you get the value here. Okay, so you just try to calculate again to this. Okay, so So your final or your test, so like this one, okay, they have the step by step calculate. Okay, so you get actually this question, okay, this is the final exam, okay, the previous final exam, okay, the question is 5 mark to this question, okay. So you get the 5 mark or 6 mark, okay. So this maybe 2 marks or 2.5 mark for calculation at 1 meter, okay. This one to 3 marks, okay. So the 6 marks for this question only, okay. So they have step by step, okay. You just okay, study balik, kira balik, okay, for this question, okay. So to understand, so any questions, ada apa-apa nak tanya? All of you can understand? Boleh okay. So kalau senyap tu tandanya faham, okay. So now we look at so this is example with the with the 4 different fluid, okay. So this example shows 4 different fluid inside a glass container, okay. If atmospheric, okay, so atmospheric at this is open to the open to the atmosphere, okay. So they have the P atmospheric here, okay. And the absolute pressure at the surface and bottom, okay, and the absolute pressure at the surface and bottom are 101.03 kilopascal and 2.31.3 kilopascal. So P absolute at the bottom is 231.3 kilopascal. So P atmosphere, the value here, okay, they give you. Okay, now you must, this step by step, you must calculate the pressure at this SAE oil. Okay, then you calculate the pressure at water. Then you calculate the pressure at olive oil and calculate the pressure at mercury. Okay, you want to find the specific, okay, specific gravity of SG. So you want to get the SG of olive oil. Okay, so the SG of oil is given. Okay, so at this example, the SG is given as 0.62. Maksudnya dia beri saya lupa nak letak kat sini. So SG of SE, okay, 0.92. Okay, water, we know that the density of water is 1000. Okay, no need to know the SG. So we know that the density of water is 1000 and SG of olive oil is want to find. So you want to find this SG, and the SG of mercury is 13.56 or ataupun selalu kita guna 13.6. Okay, so in this questions give you the mercury is this one, okay, 13.56. Okay, so now step by step. Step 1, okay, so you must calculate the SAE, okay, pressure at SAE oil, okay. So pressure at SAE oil, so must know that density of oil times by the G times by the H, okay, with the H is 1.5 with the H, okay. Maksudnya setiap kedalaman tu, setiap fluid tu perlu gunalah based on the difference depth and the different fluid. So that's why you must step by step calculate first SAE oil. Okay, so you get the pressure of SAE oil. Okay, 0.92 times by the 1000 is density of water, times by the G 9.81 and times by the H 1.5 meter. So you get the pressure at SAE oil. Okay. So pressure at water, so we know that the density of water is 1000. So you just do the 1000. Sorry. Okay, so you get the, just put the value here, okay, and you get the pressure of water with this value, okay. So the step 2 here, okay. So now step 3, so you must calculate for the olive, and step 4 for the mercury, okay. So for olive, so Sg of olive times by the density of water times by the G times by the H, okay. So we don't know the Sg of olive, okay, just put the density of water 9.81 and 2.9. So the pressure in olive is, okay, in terms of Sg olive, okay, because we to find the Sg. Okay, the pressure of mercury, so you just do this, okay, just put the value here until you get this value, okay. So soalan ni markah dia banyak so these questions actually this the previous final exam, okay, previous final exam. So after you get step by step until step 5, step 4, so now is the step 5. So you just plus all the pressure, okay, pressure from P atmosphere, okay, P atmosphere plus pressure at SAE oil plus pressure water, pressure of olive oil and pressure of mercury is equal to P absolute, okay. Yes, but P absolute is the pressure at the bottom, okay. So there's equal to P absolute here, okay. So P olive, so we know that the just stay the P olive here and the P absolute. So all the other pressure you just put to the right side. So that's why P olive here, so P absolute minus by P atmosphere plus P SAE oil, PW and PM. So is equal to pressure of oil, olive oil is this one. Okay. Based on this value. Okay, so you just solve the, okay, calculate the value here until you get the SG olive in 1.4. Okay, so soalan ni dalam 10 10 marks. Okay, 10 mark to 12 mark. Okay, so now we look at the pressure measurement. Okay, pressure measurement for manometer. Okay, types of manometer. Okay, they have 3 parts. Okay, the 3 parts of simple U-tube manometers, okay, differential manometers and inverted manometers. So this the 3 types of manometers. Okay, so now at this example here, there's the 3 of simple U-tube manometers. So we look at this is simple U-tube manometers. Okay, simple U-tube manometers, they have 2 figure here, figure 1 and also figure 2 here. Okay, so with the concept of Pascal law, okay, so you must find the level, okay, the level that you can do as the Pascal law. Okay, so based on this part here, okay, maybe you can based on this is left, this is right. Okay, so you get this is P1, this is P2. Okay, so as the Pascal law, P1 is equal to P2. Okay, so the P1 here, they're based on this left side. Okay, and the PR is based on the right side here. Okay, so they have the equation here. So they have the P1 here is include the PA. So the include of PA plus the P gauge here. P gauge in this fluid. Okay, so you get the PGH. Okay, H2. Okay, they have the H2 here because the gauge is at the same level here is the H2. Okay, and the P2 here is include the PB plus the PB plus the gauge, P gauge in here, okay? Plus the P rho G, H is H1 plus H2. Okay, so this is the concept for YouTube manometer, simple. Okay, because they have just only have two fluid. Okay, they have fluid here, one fluid, and the one fluid here, the two fluid. Okay, simple. So this is called simple YouTube manometers. Okay, so now we look at the figures 2 here. So they just also have the level here, the same level here. So use the Pascal law also. So we just put here as the P1. Okay. So and this is P2. Okay, sorry. P2 and this is P1. Okay. So P2 is equal to P1. Okay. And the P2, oh sorry, this is P2 because this is P atmosphere. Okay, just correct the part here. Okay, so P2 is sorry. Okay, betul lah. P1 betul. This is P1, this is sorry, this is 1, this is 2. Okay, so P1 and this is P2 because this is 1 and this is 2. So this is P1 and this is P2. Okay. So P1, P2 and P1 is the same. Okay. Okay, and we know that the P2 here is include the P atmosphere plus the P rho GH here. Okay, so this is called P2. Okay. Okay, but P1 is based on the pressure on gas here. Okay, so the P1 is the pressure of gas. So that's why the P1 is, we just put the P1 is equal to P2. Okay, so the P1 is equal to P2. So we get the value here. This is based on this concept. Okay, this the second diagram. So now this is usually mercury is used to measure height gas. So this is concept here based on the figure. Okay, so the consider left and right side here. Okay, consider the left and right side. Okay, the left and the right. So based on the figure 1. Okay, this is mentioned for the figure 1 that I okay, from the previous slide. So this figure 1. Okay, so P atmosphere is 0 as datum. Okay, kalau dalam soalan P atmosphere is not given the value of P atmosphere, so you assume as 0. Okay, kalau P atmosphere is given value, so you use that value. Okay, kalau dalam soalan tak diberi nilai P atmosphere, so we can assume as 0. Okay, you boleh guna sebagai 0. Kalau diberi, so you gunakan that value. Okay, so P atmosphere is 0. So as datum, therefore, PA, so PA plus density of A times by the G times by the H2 is also equal to the density of B times by the G times by the H1 plus H2 because the atmosphere is 0. So no atmosphere. So this is 0. Okay, so they mention as the 0. Okay, no P atmosphere. So we get the value of this is the equation for figure 1. Okay, from the previous slide. Okay, actually for figure this one. Okay, so you get here. Okay, PB is the P atmosphere. Okay, so we get actually is 0 because this is atmosphere. Okay, so we get this equation for figure 1. So now we look at this is actually for figure 1 also. So this is example. Okay, so calculate pressure at A to get the pressure at A. Okay, with the B here, the pressure of B is given. Okay, calculate pressure at A in kiloliter per meter square if H1 is given as 50 mm, H2 is 102 mm, density of A water here, 1000. So this is water. Okay, and the density of this mercury is, okay, so this is for mercury. Okay, the P atmosphere is not given. Okay, in this example, P atmosphere is not given the value. Okay, so that's why we can use as 0 for atmosphere. Okay, that's why the atmosphere is 0. Okay, because these questions, the P atmosphere is no value, so we can assume as 0. Okay, P atmosphere is 0. Okay, so now we look at the consider left and right side of manometers. Okay, P left, okay, PA plus the rho WGH2. Okay, so this is based on this side here. Okay, actually for this side, left side and right. So this is left side, this is right side. Okay, so we get the left KPA plus the density of water times by the G times by the H. Okay, so we get the PA for left side. So now look at the right side. So they have no atmosphere. So no atmosphere here. So they just include the big gauge here, H1 plus H2. Okay, so H1 with H2. Okay, so you get the value here. Okay, so you just the left and right is the same, left and right. So you just put the same here, PA plus 1177.2 and is equal to this. Okay, so until you get the PA is side. Okay, any question of this example? Ada siapa-siapa nak tanya? Semua okay? All of you can understand this concept? Yes, okay. Okay, Alhamdulillah. Kalau yang senyap tu, yang tak faham tu, tak apalah kalau tak faham. If you don't understand, so you can text to me. Okay, maybe you can message or PM. Okay, so now, so this is the concept pressure. Okay, so that's why you must know the equation in topic 1 and you can apply to topic 2. Okay, so the pressure. Okay, so pressure, use the Pascal law. So this is more on pressure in manometer. Okay, so now we look at the also manometer, the same. This is at the figure 2. Okay, figure 2 based on simple U manometer. Okay, a manometer is used to measure the pressure in a tank. Okay, the fluid used has a specific gravity. So the fluid, okay, the fluid here, 0.85. And the manometer column height is 55 cm. The height is the 55 cm. Okay, if the local atmospheric, so these questions they give you atmospheric pressure. Okay, so dalam contoh soalan ni atmospheric pressure is given. Okay, so you must use this value. Okay, the previous slide example, the atmospheric pressure is not given, so that's why you must use 0. Okay, 0 for P atmosphere. So this example they give you the value of P atmosphere. Okay, so for solve this question, so you must use the Pascal law concept. Okay, cari mana yang level yang boleh untuk you kira. So find the level at the same level, okay, with the same fluid. Okay, so cari level with the same level and with the same fluid. So you get the pressure at point A and pressure at point B. Here, okay. So we get the PA using the Pascal law. PA must equal to PB. Okay, this is the Pascal law concept. Okay, so now use this equal. Okay, so using the, okay, just look based on this one. Okay, PA is actually for this one. Okay, so PA based on the PA. Okay, so PA is pressure at A. Okay, based on the this side. Okay, and PB here at this side. Okay, so there's the P atmosphere. plus the P gauge here. Okay, so the rule, there's the fluid. Okay, the rule of fluid here. Okay, G H. Okay, so H is you must convert to meter. Okay, so P atmosphere. So you just calculate here. So P atmosphere plus rho GH here. Okay. So the P atmosphere, so actually this is PA. Okay, so P atmosphere is 96 kilopascal. Okay, the SG of this fluid, SG 0.85 times by 1000. Okay, so you get the density of this fluid is this one. Okay, that's why you put here density of the fluid. Okay, and the G is 9.81 and the H is 0.55 meter. Okay, okay. So I use this 1 Newton per kilonewton for this one because this is used the kilopascal. Okay, that's why we use this part here. Okay, so if you can convert, okay, no need to use this unit here. Okay, kalau you boleh tahu nak convert dia macam mana, so tak perlu letak this one ni. Okay, so because this is kilopascal, that's why I just put here to show to you how to from the Newton meter to convert to kilopascal here. Okay, so we get the value of PA here as the kilopascal. Okay, soalan untuk pressure ni dia direct. So pressure question for this pressure is direct question. Okay, based on manometer and based on the Pascal law. So this pressure, so you must use the Pascal law. Setiap pengiraan based on manometer and so on, so you must use the Pascal law concept. Okay, at the same level with the same fluid, okay, with the same fluid and with the same level, so you must use the Pascal law, or the direction is the same. Okay, so now we look at this is differential manometer. Okay, manometer yang berlainan, maksudnya dia guna fluid yang berbeza lah. Okay, so they have the point at the point 1 here to the point 2 here, so they must go through this manometer. Okay, so measuring the pressure drop across a flow section or a flow device by the differential manometer. Okay, so fluid dia akan melalui dalam sini dulu flow device, lepas tu dia based on go to point 1, okay, until go to point 2. Okay, the base fluid from this device. Okay, so this is concept differential manometer. So a relation for the pressure difference P1 minus by P2, because the P1 minus by P2 can be obtained by starting at point 1 with pressure at 1. Okay, P1 here. Moving along the tube by adding or subtracting the rho GH, okay, based on the gauge terms until we reach point 2. Okay, this one until reach to this pressure at 2. Okay, and setting the result equal to pressure 2. Okay, so we must know that assume first, okay, at the same, this is the same fluid, okay, with the same level here. Okay, you can using the Pascal law, so you put here as the pressure at point A is equal to pressure at point B. Okay, so that's why we use the pressure at point A equal to pressure at B. Okay, so now we look at the pressure at point A first. Okay, include here. Okay, and pressure for B is include here. So PB. Okay. Right, left and right side. Okay, this is left, this is right. So this is PA, this is PB. Okay. So at PA, so they just consider the pressure at 1 here. So that's a pressure at 1. So that's why we put pressure at 1 plus the pressure gauge along this fluid. Okay, so that's why pressure density 1, okay, because this is the fluid 1 here, density 1 times by the G, okay, times by the height of this fluid here. Okay, So the height is A plus H. So that's why you use A plus H. Okay, for this concept. Okay, for at the A, and the PB is here. Okay, so now you look at the part of the right side here. So they have consider also the pressure at 2. So that's why you have the pressure at 2. Okay, and also consider the pressure of this. Okay, this is density 1. Okay, density 1, because this is the flow, the same fluid. Okay, this is from this one is the same fluid until to this one. Okay, so this fluid 1. So that's why you use the fluid 1, density of fluid 1 here, times by the G times by the A, because the depth of this fluid is A. So that's why you use A here. Okay, so this one. And then plus also the density 2 here, fluid 2 here. So that's why you use the fluid 2, density 2 times by the G times by the H. Okay, so this is differential manometer, because you must consider the pressure at 1 here. Okay, pressure at 1 here and also pressure at 2 here. So that's why you have pressure 1 and pressure 2 here. Okay, so until you extend the equation here until you get this one, and just put the P1 minus by P2 and you get the real equation for this differential manometer. Okay, actually this is differential manometer for this concept. Okay, so this is the differential manometer concept there. So you must consider the pressure at 1 also and pressure at 2 here. So that's why you mention here as the differential. Okay, pressure the ada perbezaan differential manometers is based on P2 P1 until to P2. Okay, so that's why we call it is differential manometer. Okay, this is concept. Now we look at this is also the concept of differential manometer here. Okay, so they must consider also this PA and the PB. Okay, because this is not open to the atmosphere. Okay, so they must consider the pressure gauge in this tank and also this tank. Okay, so now we look at the consider left and right side. So this is called left and this is called right side. Okay, so at the left side here, this at the left side here is consider for this. Okay, and for the right side is consider for this B, the right side. Okay, so now look the left side here. So they've considered the pressure at A and also the pressure of fluid here. Okay, so that's why pressure at A plus pressure in this fluid. The fluid A is density A times by the G times by the H2. Okay, and the P right here, the P right here, the consider for pressure at B and also pressure at this fluid here. Okay, the density of P, okay, B, and also the P. So this is a PA. So this is also PA based on the density area GH2. Okay, and this one PB rho B GH3. Okay, and this one is P. Okay, P, this is the PA. So kita buat PA lah. So mungkin sama based on. Okay, so this is PA, maksudnya yang sama ni adalah this is PB, density of this B, this is density of this area. So maybe we call it as the PC. P of this fluid, PC G H3 minus H1. Okay, so you just correct this one as the PC because we don't know that the fluid here. Okay, okay, kalau fluid dia sama, okay, based on PA here sama keseluruhan sini. Okay, maybe the same fluid here. Okay, so for this concept, so they give you the fluid, the same fluid. Okay, with the same fluid here until for this part. Okay, so that's why we use as the A here. Okay, so mungkin dia punya fluid sama dia punya salah. Okay, so we use as the A. Okay, so maybe the fluid of from this A until to this part is the same. Okay, the same fluid. So that's why the Px right here, Pb, we use the Pb here, density of B. Okay, and also the density of A. Okay, GH3 minus by H1. So just put to the left side and the right side, so you get the PA and the PB here. So the PA is the same here. So maybe is the same liquid here. Okay, so that's why we use the differential manometer PA minus by PB. So PB GH1 plus PA, because the A is the same liquid. So H3 minus by H1 minus by H2. Okay, so this is concept for this differential manometer. Okay, so this is for this figure. Okay, so this equation, okay, for this figure. Okay, for this figure, the differential manometer is for this equation. Okay, so they have two figure for differential manometer. Okay, so use the concept. So this is based on, okay, so this from this figure, okay, from this equation that you get, so you find from this question here. Okay, so for this, okay, for this figure, below show differential manometer used to measure pressure inside a pipe. If PA minus by PB is 120 kilopascal, find H to find the H here. Okay, so this is water, so this show the SG of water is 1. Okay, this is mercury. Okay, so you must consider the here. Okay, left side here must consider with Pascal law. This is right side. Okay, so you use the left side and right side here. Okay, so left side is consider of PA, left side is consider of pressure at A, and also pressure water in this height. Okay, so in this height we have H, and also we don't know the H here. Okay, so you must know the H here. So you must use the HA plus H. Okay, HA here, this is H, so this is called HA. Okay, kita letak this sebagai HA lah, sebab we don't know the HA of this. Okay, so we get the HA plus H for the left side. Okay, the density of water for the left side. So we get in terms of this equation. Okay, HA and plus the H. So now we look at the P right here. Okay, so we look at the P right. So the include also the PB. Okay, and also the pressure, the density of B here with, okay, with the PM of mercury. So mercury is this one. Okay, density of mercury times by the G times by the H. Okay, for the mercury here. Okay, the mercury. Okay, and also the water. Okay, the water here. Okay, density of, okay, density of water times by the G times by the 1.6 plus HA. Okay, the depth here. Okay, so for the water, for the mercury here is density of mercury times by the G times by the H. Okay, so that's why you get this value. Okay, HA or HB. HB is 1.6. Okay, HB is 1.6. Okay, this one. Okay, is called as the HB. This one, HB. Okay, HB. Okay, so X right, PB plus SG of mercury times by the density of water times by GH, and you just put the value here. Okay, and plus the density of water 9.81 and times by the HA plus 1.6. Okay, so the PX right is in terms of HA and H. Okay, H and HA. Okay, so now you just consider for the left side and right side. So you just put here. Okay, with the HA and the H. Okay, so you just PA minus by PB. So you in terms of H, okay, HA ni nanti you akan tolak lah. So dia akan jadi kosong. HA and HA. Okay, so 3H saja. Okay, and this one. So you get the H of this one minus by H this one and the value of this one. Okay, so you get the value of H is 0.8544. Okay, any question at this part? Semua boleh Okay, kalau semua senyap tu semua faham dah. So you can, okay, after this I will give this, okay, video record, okay, recording video. So I will give to you. So you can look back, okay, to study. So now we look at the inverted manometer. Okay, so we have studied the simple U-tube manometer. We studied the manometer, sorry, the multi-fluid, okay, the differential manometer, and now is inverted manometer. Okay, so inverted manometer is the dia kat bawah maksudnya dia punya manometer kat bawah sini. So that's why we call inverted manometer. So mercury is used to measure pressure if fluid is low density, especially oil. Okay, consider left and right. So we must consider left and right also. Okay, base take at the same level here. Okay, with the same fluid, so we use this one. Okay, so left and right. Okay, so we consider the PS left and PS right. Okay, so we look at the PS left here. Okay, so they consider the pressure at A. So pressure at A, so because the flow is up, okay, up to this point, so the mass negative. Okay, that's why the mass negative here, density of A times by the G times by the H2. So the depth of this fluid is H2. Okay, minus by this P air. Okay, density of air. So density of air times by the G times by the H1. So you get this value. Okay, so neglect P air. Okay, so kalau dia cakap neglect P air, kalau dalam consider in your test or in your final neglect P air, so nilai air tu tak ada lah. Okay, so there's no air. So just only have this one. So now we look at the P right here. Okay, so P right at this part here. Okay, so P right is based consider on PB, pressure at B, minus by pressure at the same fluid here, PA. Okay, that's why the PA times by the G times by the H3. Okay, the H3 here. Okay, minus by also the A here. Okay, density of A times by the G times by the H1. Okay, so we get this one. Okay, so we get the PS right is this equation. Okay, so we get the PB. You just extend the equation here, you kembangkan. So maybe tak kembangkan pun, you just jadikan the H3 plus H1 here. Okay, so you get the PB. So now you just put the P left and the P right here. So just put this one, PA and the PB here. Because this is neglect PA. Okay, PA is ketempatan dia rendah because udara maksudnya udara dia kat sini ketempatan rendah, so that's why the just neglect the density of air. Okay, so that's why just only have this equation. Okay, the PA minus by density of A GH2 and the right side PB, okay, minus by density A G H3 plus H1. So we get the value of this inverted manometer. Okay, so this is the concept for get the equation for inverted manometer. So now we look at the example here. Okay, so this example show inverted manometers used to measure pressure inside a pipe. Okay, find the pressure difference PA minus by PB. So you must look at the same level here. So you just left and right side. Okay. Okay. So left, just consider the here. Okay. And right side, you consider the. So the left side, okay, consider the PA. Okay. Pressure at A. And density of water times by the G times by the H here. Okay. 1.625 meter. Okay. That's why you get the PA minus by density, the pressure at A minus by the density of water here times by 9.81 and 1.625. So you get the X left here. So now you look at the right. So the right is based on the pressure at B minus by density of water with the height of 1.625 minus by 0.25. So you get the height here. Okay. So this H, so you get the 1.625 minus 0.25. Okay. So that's why you get this one. Okay. So you akan dapat lah. So you get the PB, density of XG, density of X here. Okay. So the fluid X here, SG. Okay. Minus by density of X. So that's why you get the density of X times by the J times by the HB. HB is 0.25. Okay. HB is 0.25 here. Okay. So X5, so you get the, put all the value here until you get the PB is this one. Okay. And just put to the left and side, right side. So you get the PA minus by PB. You get the pressure. Okay, pressure for inverted manometer. So you get this one. Okay, so you get the HC. Actually, HC is for the this one. Okay, 1.625. Okay, 0.25. You get the H here. Okay. Yeah, so this is also the same inverted, and this is multi-fluid. Okay, so pressure measured by multi-fluid. So after you get this one, okay, so you now look at the example here. Okay, so based on the multi-fluid manometer as shown in the, okay, shown in this figure, so the tank is located on a mountain. So they have the here. Okay, so actually soalan ni pun soalan sorry, this is final exam. Okay, the previous. Okay, so you must find the which is the you want to get the Pascal law. Okay, so this is the same fluid. So you just put here as the same. Okay, it's the left and right. Okay, so this is just do for this one. Okay, the left and right side. Okay, so we get the P atmosphere is this one, and H1 is 0.1, H2 is 0.2, and H3 is 0.35 meter, and density water is 1000. Okay, density of oil is given here, and density of mercury is given here. Okay, so all the parameter in this test is given. Okay, so you just put the given data here. Okay, so you look at the side here and the left side. So just put the left, pressure at left is equal to pressure at right. Okay, pressure at left and is pressure at right here. Okay, so first you just look at the right first here. Okay, the right is actually is consider the pressure atmosphere. Okay, and also pressure H3 here, mercury. Actually, this is mercury. Okay, and the mercury actually this one. Okay, so P atmosphere actually plus mercury. So when the mercury is go to this side here, so there's the negative. Okay, so this is the so actually this okay, the equations dia lagi panjang ni saya dah pendekkan. So I just short the equation. Okay, actually from the right, so go to this left side here, the mercury. Okay, so we get the for this left side. Okay, so now at this side, So they just consider the pressure at 1 here and also consider the pressure of water. Okay, density of water at the H1 also here. Okay, H1 minus by H2 and minus by H3 and so on. So until you get this one. Okay, so the oil also, this is oil. Okay, so the oil is density oil times by the G times by the H2 and H. Okay, they have H1 and H2 untuk oil Maksudnya oil ni dia ada sebab dia oil kat sini so they just include also the H1 and also the H2. But after we calculate, so we get only this one. Okay. Sebenarnya dia panjang lagi untuk dia punya calculation, but I just shortcut the after tolak plus and minus, so we get the left side here is P1 plus density of water times by the GH1 plus density of oil GH2. Okay, and this is actually from the right side. We just put to the left side here. Okay, until we get the value of P1 is 130 kilopascal. Okay, so yang this equation I will give you the long, the long equation. Okay, so actually this is the short equation after plus and minus from this part from the multi-fluid here, oil, water, okay, and so on. Okay, so dia banyak maksudnya based on water with the H2, okay, with the oil with the H1 and the oil with the H2. Okay, so they have actually oil, they have the oil with the H1 and they have the oil with the H2 and the oil with the H1 plus H2 also. Okay, the 3 type here. So there's one here and the one or H1 plus the H2 also. Okay. So nanti dia ada the equation is so long. Okay. This in this example I just give you the short equation after calculation plus and minus. Okay. And until we get this one. Okay. And last we get this. Okay, so to be continued in part B. Okay, so if you have any question based on the example, so you can ask here. Okay, before we stop our class. Okay, ada siapa-siapa nak tanya? Semua tak ada Yang mana? Oh, yang panjang ni. Nanti saya akan bagi dalam satu slide. Okay, untuk yang this is shortcut maksudnya pengiraan yang saya dah pendekkan. So nanti yang panjang ni nanti saya akan bagi. Okay, saya akan bagi yang saya tulis tangan senang. Okay. Okay, any question? Tak ada All of you can understand. Boleh semua boleh faham? Okay, kalau semua boleh faham. Okay. Okay, to be continue. So we continue our part B in Thursday. Okay, Thursday. Okay, on Thursday we start our class at 8:15 Maksudnya pukul 8 suku nanti kita start. So we start our class Thursday at 15. Okay. So I will give you links or just we use the same link Okay, maksudnya kita gunakan link yang sama untuk Google Meet. So we use the same link for Google Meet for Thursday class. Okay, that's all. Okay, Assalamualaikum warahmatullahi wabarakatuh. We see you on Thursday. Okay, if you have any questions based on this topic part A, so you can ask based on PM to me. Okay, that's all. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih semua. Okay, thank you.